My name's Luke, coming at you from the house today because, I'm recovering. But I figured at least keep busy while I'm sitting around instead of just being a vegetable. So when we're talking EFI conversions, how do you convert an old engine to EFI that didn't originally come equipped with it? And the answer is the same way the OEs did it, which most of them just put a sensor in one of two spots, and the sensor is with a toothed wheel, so they could count. Whether it was on a flywheel like Jeep and Chrysler did, between the bell housing, they just notch it, and the notch got picked up by a Hall effect switch or a VR switch, every 90 degrees, or I think there was 8. But basically that tells you, divide that number, and that gives you the approximate amount of control it can have relative to, and how accurate it'll be as far as the ignition system. Ford did it with their motors. It was a little 36-1 wheel, which is probably one of the most popular conversion wheels to this day. You can get these wheels cut and made. There's companies that make them already. American, European stuff. The American stuff tends to be bigger. It's more focused towards like doing a V8. But there's some European companies out there doing stuff focused towards like much smaller, like motorcycles, ATVs, much smaller. So we're going to discuss the two main things needed to get a proper EFI system up and running, which is a minimum crank trigger sensor and preferably a cam sensor. So we'll start off with the one that's for the 440. So here we have a 3-wire Hall effect sensor. I prefer these. They're simpler. You don't have to wire in softeners like you do for VR sensors or resistors to help bring the voltage down to a respectable level. And they're really cheap. $30. They work. And how that works is just reads off the wheel like that there. It's mounted a certain distance or accurate to like a 1/4 inch or so. And as that spins, it's just counting the teeth. So each one of these teeth, it's a 36-1, so people would be inclined to believe that if you don't think about it in long math quite right, remember there's an upper tooth and a lower tooth made by the valley and the peak. So each one of these is actually 5 degrees. So, and there's the missing, so 36-1. So basically that makes this a 36-1. Each tooth is approximately 5 degrees of arc, and the computer uses this Hall effect sensor. If you see one of these but it's only got 2 wires, it's a VR sensor. So VR sensors, the difference is they make their own juice. A Hall effect, you have to provide 5-volt signal and stuff to it, and a ground, and then it sends your signal back through that wire, the actual sine wave. All right. And then the next thing, so that's your crank sensor. This can go, and how the actual one for the car that I have is going to work. This is going on to a 48, or not 48, a 1978 big block Chrysler. It's a my Challenger. This goes on to the pulley, and like so. This has all these fancy brackets and such to go with it. I worked with a company that prototyped this for himself, and had him carve me up another one. Pretty good company, good people to deal with. So, various pigtails for things we'll get into here in a second. And then the next piece that they made was a piece to convert. This is where you'll hear the phrase the CPS bushing. That's this guy right here. So this is actually Jeep 4-liter distributor for the fuel injected later inline 6 Jeeps. This bushing bushes this whole thing to the same size and height required for a big block Mopar. So it just bolts in there, drops down in where the original distributor went, but it's much smaller head. And using this in conjunction with this allows me to run sequential spark and ignition and fuel. Sorry, spark and ignition will be the same. So that's the big boy stuff. Now I was talking about doing it with motorcycles and stuff too. Well, you can. So there's an old series of Yamaha motorcycles and ATVs that I'm working on. I'll make it fuel injected because I don't like carburetors when they cough and spit going through the woods. I don't like having to choke them. I don't like messing with them all the time. That, and there's power to be gained typically with fuel injection on the single cylinders, especially because you can run so much bigger of a throttle body that you can help uncork things somewhat. So right here we have what was an old stator cover for Yamaha, and it has obviously this wheel. Now this wheel is nothing more than been a machined and repurposed flywheel for that. This is where you normally would engage your pull start, but it has access to the crank that's splined and interchangeable. It's not master splined in one particular area. So I can get this really close to where it needs to be, and then I can set the offset to get final timing right on the engine. And I have a timing port right up here on this cover. So this covers that piece. Well, how do I get a Hall effect sensor? Well, this is a universal Hall effect sensor. And I built this cover on 3D printing. Basically reverse engineered the whole pattern and figured out how to make it all fit. This slides over this. The sensor just bolts right in the top. Slides all the way in, of course, to about there. Bolts down, and it'll read that wheel. So for now, this is just because it's cheaper and more effective. Made it the first copy out of plastic. I'll eventually make another copy out of aluminum. Probably machine it next year on a CNC machine. So that's how you can do motorcycles. Now, some motorcycles, they don't always have the luxury of a big pull starter. Well, that's okay, because I've seen guys also take the same wheel I did and basically grind it down until it's a wafer, and it's something they could slide over and still fit inside of the actual stator cover, and then just put a boss and a sensor on the original stator cover. So it's very possible to do it. The next thing you need is cam sensor, which most of these engines have some sort of cam cover, so it's very easy to pick up a sensor, because a cam sensor for most, EFI systems doesn't need to be overly complex like what the OEs use. It can just be a 180 on, 180 off. You're just telling, basically the cam sensor is just telling you what cycle exactly out of the 4-cycle sequence the motor's on. Because every four-stroke motor, no matter how many cylinders it has, spins 720 degrees or 2 360-degree rotations to fire all of its cylinders, whether it's got 2 or 20. So with that in mind, it just tells it, okay, I'm on the first cycle of cylinders in the first rotation, or the second cycle with a 180 sensor. But that's enough to give you fully sequential spark, fully sequential fueling, and individual fuel trims, all the good juju. So today's video, like I said, this just covers the cam and crank sensor stuff. We're not really getting super in depth with it today, but I'll make more videos as my neck and my voice permit me to, because I'm already starting to lose my voice. So, if you like what you see, give me a like, subscribe, whatever. I'll be doing a series of videos throughout the summer as I recover on how I'm doing this stuff. If people like it, I'll keep doing it. Take care.